Hello, and welcome to the Intelligent Autonomous Systems Research Opportunities webinar, hosted by the Army HBCU-MI Student Program for Army Research and Knowledge, or SPARK. Today's webinar aims to provide information about ways colleges and universities can collaborate with the U.S. Army Combat Capabilities Development Command Army Research Lab, or DEVCOM ARL, and our partners on research opportunities in intelligent autonomous systems. Today's speakers include Dr. Robert St. Amant from ARL and Dr. Amant Solomazou and Gabe Monroe from the U.S. Army Engineer Research and Development Center, also known as ERDIC. Our speakers will provide information for roughly 45 minutes. And then for the last 15 minutes, we will open the floor to any questions that you may have. Now, my name is Crystal Nolan, and before we turn the presentation over to our Army speakers, I'd like to discuss the webinar format for just a few moments. We ask that you keep your microphone muted during the presentation today, but during the Q&A, we'll invite you to open your mic to ask any questions that you may have. You can also use the chat feature to ask questions at any time. If you use the chat for questions, we ask that you include whether your question is for the ARL or for the ERDIC speakers, so that the right person can answer your question. If you have any questions about using the Zoom platform for this event, please feel free to enter your questions in the chat window right now. Technical support is on hand to help you with any issues that you may have. And with that, I will turn it over to Dr. St. Amant.
Thanks very much for your introduction, Crystal. So I am, and good afternoon, everyone. I am a program manager at the Army Research Laboratory, and it may be useful if I give you a little bit of background on the structure of ARL. ARL is in an organization called DEVCOM, the Combat Development Command. ARL has 3 directorates, top-level units. One is the Army Research Directorate, and that is about 1,500 scientists and engineers engaging in research of interest to the Army over all scientific areas. Another is the Research Business Directorate, and that handles administrative activities and management and so forth. The third directorate is the Army Research Office, and that is what I am part of. ARO is responsible for sending funding out to universities and other institutions that engage in research, and they write research papers and do all the basic research that we in the Army might be interested in. This presentation is to give you a bit of insight involved with either ARO, that is the external arm of ARL, or ARD, which also runs programs that engage with universities. Next slide, please. I'm going to focus on robotics programs, in part because this presentation was developed by Marianne Fields, another program manager in my branch at ARO. My branch is military information sciences, and that includes the topics that fall under the umbrella of robotics. So we have all of these are taken from the ARL Broad Agency announcement, or BAA, which you can find online. In previous years, ARD and ARO released separate BAAs for the separate programs that they wanted to, the directors wanted to support. But this past year, for the first time, the BAAs were combined, so it's all in one place. The topics include improved platforms, enabling AI science, enabling data science, improved computing, improved machine learning, network systems, and so forth. The one in the middle, autonomous action and operating in the real world, is one that falls under Marianne's program, Advanced Learning Enabled Intelligent Cyber Physical Systems. Her specific interest is in robots that can operate in the real world for an extended period of time autonomously. So if you're familiar with robotics research, you'll know that it involves platforms that require a fair amount of tinkering to get going. And when they do run, experiments tend to run for a few minutes to a few hours. The Army sees a future in robots that can be sent out into the field to operate on their own for days up to weeks. And that poses challenges for both energy and materials, and even such things as doctrine, so tactics and so forth. But from Marianne's point of view, and from my point of view, because we're both in the military information sciences competency, we are interested in the robot's computational and cognitive capabilities that allow it to move through the world and understand things that it may not have encountered before, and react reasonably to both unexpected events and or threats, or non-threatening encounters with people or animals, or other sorts of possibilities. So I could, well, I was going to say I could go into that amount of detail on each one of these topics, but you're probably better off reading the BAA and seeing what matches your own background and interests. Next slide, please. Okay, so how does engagement with ARO work? Typically, it involves finding a program manager who is in charge of a specific program that overlaps with your current or future research. And as Marianne puts it, the idea is to get the program manager interested enough to talk with you directly. So this means basically just sending email to someone whose name and email address you find in the BAA, and say, here's who I am, here is the research that I'm doing currently, and if not currently, then explain why you are interested in this research in the future. Just a few sentences, enough to connect your research to an Army problem. And the problem that you're connecting to is something that you have read about in the BAA. Next slide, please. So after an initial email introduction, what usually happens, at least in my case, is that I will send back a message saying that either I'm interested in talking further or not. And I'm almost always interested in talking further, because there's hardly enough information in your introduction for me to tell whether there's overlap or not. unless it's very obvious that there isn't. And so I'll send a list of I'll suggest that the person I'm corresponding with write a short white paper of 3 to 5 pages, and I'll include a list of the things that I expect to read in the white paper. I'll ask what the topic is and why the topic is important. Now, ARO is a 6-1 research organization. And by 6-1, I mean basic research, which is exploration of phenomena with no specific application in mind. So I will often get queries from companies who say, hey, here's an AI project that we're working on, and here is the product we would like to sell the Army. And I have to say, sorry, we're only interested in my program in ideas that might be deployed way down the line in sometimes 20, 25 years. So we have to think, and it's not that the Army is not interested in immediate solutions, they are, but those are handled by different folks from me. And so when I ask about what the research questions are, these need to be basic research questions with no, there should be the suggestion that they're in the right area for the Army to be interested in, but they don't have to have solutions that can be put in the field right away. So it's typical to say, here's a gap in the existing knowledge of the field, and you want to address it, and or perhaps you're going to propose a new direction for the community. You'll have to explain what's new or unique about your approach. In part because there are only about 40 program managers in ARO. And as I mentioned, we have to cover the entirety of science that might be interesting to the Army. And what this means is that we have broad but very shallow knowledge of even of the fields that are covered by our programs. So my program is called Knowledge Systems, and my PhD is in computer science with a specialization in artificial intelligence. But as you probably realize, just from that description, there are so many areas of AI in which I cannot be an expert because I don't have the cycles to have done that. So I'll have to leave it up to the person I'm talking with, or to the white paper, to explain what's new and unique about the approach, why the proposed research is important, what its significance is, where it could lead, and the connections to the whatever is in the program description that you're attacking. And Marianne writes that this isn't a proposal, it's a way to encourage conversations with a PM. Ideally, I get excited about the topics that are covered in a white paper. I think about where it could lead, and this is partly because you've informed me about where things could go. And I see how it fits in with other work in my program, and if possible, I encourage it. Next slide, please. So a few additional ideas or strategies involve reading the BAA and always leading with the science. It's good to be persistent because no one is at ARO is going to take offense if you write 2 or 3 or 4 email messages, even to different PMs, although it is helpful if you say you've gotten in touch with other PMs and whether they've responded or not. Now, here's something that's a little bit subtle. You may have an idea from reading the BAA about what the Army's problems are. And Marianne advises that you don't actually propose to solve that problem, in part because we don't describe all of our problems, all of the Army's problems, in all of their gory details. So the BAA stands for broad agency announcement. But everyone calls it a BAA. So if you type ARL BAA into a Google search bar, the right thing should come up. What ARO is interested in is enabling research. that can help the Army implement its solutions. And this is the point of basic research in any case. It's to enable more applied research down the line. What happens is that we'll get proposals, we'll get white papers, review them. It may take actually a few days to weeks, but eventually we'll get back with comments, and we will encourage proposals or not. One final favor you can do us is to offer to review proposals for us. It takes, we need to get several external reviews of the proposals we receive, and to get one reviewer typically takes 3 or 4 email messages to people who refuse or ignore us, which is fine, but it is helpful to have more reviews. Next slide, please. So proposals are submitted through grants.gov, and as I just said, ARO uses these reviewers. The technical portion of proposals is 22 pages, but that's not purely technical. If you've written an NSF proposal, which is 15 pages plus additional material, that is a good model to go with. You want to avoid buzzwords. You want to link to current work if possible, and you want to lead with the science. Not the practical benefits down the line, but what the science you're doing is how that's going to be important. One of the things you haven't done in your white paper, because there hasn't been room, is add technical details. Here you can do that. Next slide, please. And that's it. I encourage you to contact me or Marianne, and at the end you'll be able to see our email addresses, and I'd be happy to talk with any folks who are in the area of artificial intelligence, who are interested in helping the Army. Oh, and I apologize for not showing my face here. It's because my camera doesn't work with Zoom. But thanks for your attention.
Okay, thank you for those valuable strategies, Dr. St. Amant. And next, I would like to welcome Dr. Ahmet Solemezalou, and I would like to ask that you please pardon me if I have pronounced your name. But
not a problem at all, ma'am.
Thank you very much. The doctor is from the U.S. Army Engineer Research and Development Center, or ERDIC, as we spoke about earlier. And he's going to talk about some intelligent autonomous systems research opportunities. And so I'm going to turn it over to the doctor now.
Thank you very much, and good afternoon, everybody. Can I get a real quick comms and mic check? Can you guys hear me well?
Yes. Yes, we can.
Fantastic. Once again, good afternoon. I'm Ahmet Solemezalou with Engineer Research and Development Center. And today I'm going to talk to you about some of the robotics and autonomy type of research that we have undergone here. But I'll start with giving you a quick overview of who ERDIC is and how it fits within the Army SNT community. Some of you might be familiar with the more well-known entities such as DEVCOM, as my colleague explained to you a little bit ago. And then I will have some technical information about some of the efforts, maybe to initiate some conversations, and then I will pass it on to my colleague in ERDIC South. So with that, real quick, here is what the ERDIC enterprise looks like. As I said, a lot of the universities that we collaborate with are familiar with the Combat Capabilities Development Command, DEVCOM, and ARL, etc. And we, sometimes get the question of what in the world is an ERDIC anyway. We know DEVCOM, we know these other entities. What is ERDEC? So ERDEC is one of the big 5 R&D enterprises within the Army. We have our own 3-star command. We are under the U.S. Army Corps of Engineers, and the Chief of Engineers is our boss. He's a 3-star general. And the Engineer Research and Development Center is the research arm for the Army's engineers, as well as we are also in charge of the civil works infrastructure of the nation. So under ERDEC, we have 7 laboratories. As you can see on the map here, the headquarters is in Vicksburg, Mississippi, which is where we have 4 of our laboratories. I am from the Construction Engineering Research Lab in Champaign, Illinois, and we have the Geospatial Research Laboratory in Alexandria, Virginia, and we have the Cold Regions Research and Engineering Lab in Hanover, New Hampshire. So as the names might suggest, a lot of these labs came into existence because of their core competency areas. You know, a lot of the work in the EL laboratory started with environmental engineering, but as the problem space of the Army got more complex, this is a very cross-matrixed organization now, working, collaborating heavily with each other under one big umbrella. So the Corps of Engineers Chief Engineer has recently published the top 10 Army Corps of Engineers R&D priorities. These are not in particular order here. They're just a flat list of 10 things. So this is our guiding document to perform research within ERDEC. So there is a, you can scan that tag and actually download this document if you're interested in the problem spaces that we operate in, and you know that might give you some ideas about the types of research that we're interested in. So, as I said, Corps of Engineers is an interesting organization because we serve 2 separate communities. So we serve the Army's combat engineers, as well as being in charge of the Army's civil works infrastructure. So we monitor, maintain, build the nation's waterways, dams, locks, gates, etc. Also, the Corps of Engineers is in charge of any large-scale construction that is outside of the United States, continental United States. So as a result, we develop a lot of robotics capabilities that span the spectrum of operations. So I will give you some additional detailed information for some of the military things here, but the idea here is that, you know, the 7 labs under the ERDEC umbrella develop these capabilities, and then we have applications of it both for the military side and the civilian side. Okay, now I'm going to switch over to some more technical information here. I am actually in charge of an R&D program called Robotics for Engineer Operations. So the primary objective of this R&D program is to build unmanned engineer support capabilities that can operate in undefined and uncontrolled environments at what we call beyond visual line of sight standoff distances. So the idea is to, if I need to summarize this in an elevator speech, pardon me, my lights went off, I wasn't moving enough. We basically want to take the soldier out of the cab of a vehicle and allow him the capability to perform his mission using robotics from a safe standoff distance. So unlike the previous speaker, ERDEC is predominantly producing capabilities in the applied research and prototype development, testing, and validation cycles. So if you're familiar with that, those would be 6.2 and 6.3. We also have a basic research portfolio as well, but it is a smaller portion of our entire effort at ERDC. So coming back to Rio, provide standoff unmanned robotic capabilities to combat engineers to get them out of harm's way. So usually research at ERDC, I have a specific example from my program here, but the overall research at ERDC is in response to what we call a capability gap. So there are centers of excellence across the Army in charge of very specific areas. So Maneuver Support Center of Excellence is our primary proponent. And those folks identify the missing capabilities that would help support our soldiers for Army's future operations. And then ERDC takes those capability gaps and performs research to fill those gaps and get products to a prototype level so that we can field test these things and help inform future purchasing acquisition decisions made by the rest of the Army. So in this particular case, what we're looking at is a unmanned reconnaissance and mapping vehicle that can operate fully autonomously. So all the other boxes within this slide are the missing components that we have identified as ERDC and built capabilities for. So as a robot, when we put something like this in the field, the first thing we need to do is to be able to localize ourselves to figure out where the robot is. If the enemy is denying or spoofing any positioning signals, we need to come up with a capability that can operate in GPS, global positioning system, denied operations, etc. So this is kind of how research is laid out. Everything then gets integrated into a final prototype and gets field tested by soldiers. So a little bit more detail about the platform here. So the idea here is that the soldier, the decision maker on the ground, is in a safe spot, and you can send this robot downrange with an end target in mind. You can give it a command such as, hey, move 5 kilometers south-southeast from our current location and show me everything that you're seeing. And the return products are on the screen as examples. We're interested in the terrain characteristics that we will be operating in. Are there any obstacles? Are there any moisture problems? Any extreme terrain features? Does the ground look like it has been? Has it changed since the last time we have driven down this road? Which could indicate somebody trying to set up a trap, etc., etc. So, as I was saying, to recap, the Army has a need. We start a program to fill that need, and then once we have a 80% solution that's in the form of a prototype platform, we take that solution to what we call soldier touch points or stage gates. So on the slide, I'm showing you some examples of some of the recent things that we have done. The way this works is we build our capability, then we go to a location decided by the Army, and we are given a mission to perform. So we train the soldiers on the capability that we have developed. We take our hands off, they run the mission with our equipment, and then we get judged on how well the system did, and take that feedback, roll it back in, and continuously improve things. So I'll show you guys, hopefully the video is coming through. It's an example of an autonomous and robotic system. So in this case, we're looking at a compact track loader that is operating fully autonomously. So the mission set here is a basic dig dump cycle. So the operator identifies a pile of dirt at one spot, and then we give the machine a target location to go and carry it. And this is being executed fully autonomously by the robot itself. So Even though on the surface this looks like a very simple thing to do, it is a very complex problem with a lot of moving parts. So the part of the research myself and my team is doing is to keep building these type of capabilities and storing them in what we call a autonomous behavior library. So as the tasks or missions get more complex, we have solutions to parts of that mission set within that library that we can pull from and execute autonomously. So there are additional R&D programs in the robotics portfolio within ERDC. So really quickly, I'll go over these, and I'll be more than happy to give anybody detailed information. So we have something called the autonomous construction of expeditionary structures. So this is basically a robotic 3D concrete printer that can build things in expeditionary environments at scale. So you're seeing some of the products that come out of this. And again, this was recently deployed in the Pacific Theater, and you're seeing some pictures from the Marine Corps building some structures using this system. Similarly, we're not only interested in ground vehicles, unmanned ground vehicles. We also do a lot of work in the subterranean area. So this is a specific example that is designed to go through subterranean pipe and sewer systems to autonomously go and place specialized sensors that continuously monitor for certain chemical signatures within that flow. Things such as TNT or other more classified materials that could indicate some suspicious activity within an area. So ground-based vehicles, subterranean, and we also have surface type of capabilities as well. So this is an example of an autonomous rafting capability that helps the Army perform what we call wet gap crossing. So this is basically an autonomous raft that can take vehicles across a river crossing. In the interest of time, I'm going to go really fast here and show you guys some additional examples of some civil works type of robotics efforts. So as you can imagine, capabilities developed for one side of the Corps of Engineers responsibility area have direct applications on the civilian side as well. So we have been in charge of developing robotic dredges, underwater ground crawlers, which can go and investigate a port area. And we also get to test all of these capabilities in extreme cold environments. A specific example in this case is robotic crevasse detection in the Arctic. Okay, just like ARL, a lot of partners, too many to list. A lot of academia are active partners in a lot of the work we do. But what I want to point your attention to is an organization, ERDC organization called ERDC Works. So this is one of our offices within ERDC that handles broad agency other announcements, other transaction authorities, and the cooperative ecosystem studies units. These are the primary vehicles to interact with ERDC, and we have some additional specialized ones. But ERDC Works, if you search for ERDC Works in Google, is your primary point of entry that run all of these programs for us. And the process is very similar to what Dr. Saint Amant has described. And finally, for all the faculty members out there, we have a very robust student and internship program within ERDC. So I have listed some of the different ways that we invite students to come work with us, either through short summer internships or more extended, year-plus long relationships. So the primary way to get this information is that link that I have on the left-hand side, which also points towards actual careers at ERDC as well. But in general, we usually have 300 plus students within our organization every summer working with us, and we thankfully get to retain a lot of that talent for longer term full-time employment opportunities as well. So with that, I will stop here and turn it over to Dr. Monroe.
Thank you, Emmett. Mic check, and can everyone see my screen?
Loud and clear.
Yes.
Over.
Excellent. So I'm going to jump right into what I wanted to share with everyone. I also work at ERDIC as well as Emmett. I work in the Geotechnical and Structures Laboratory in Vicksburg, Mississippi. And I want to talk about, this is in the robotic space, but it's on the modeling and simulation side. Whereas Emmett talked about some of the physical robotic things that we're doing at ERDIC. So just really quickly, considering, as your robotic system becomes more complex and as the consequences of failure increase, it's more important that you understand its limitations, what it's capable of, how a dynamic environment can impact its performance, and mapping out the limits of where you should and should not use a particular platform. So obviously, you see that little graphic I have there on the top right. You probably don't need to do extensive parametric environmental simulations with a Roomba. But as the system becomes more complex and as you have less control over the environment, it's more important to do comprehensive testing and evaluation of that platform. But it also becomes more difficult. Even Tesla, which is not, autonomous vehicles is not an easy problem at whatever scale, but it is easier if you get to assume that you have GPS, that you get to assume that you're running on a paved surface with lines and streetlights and signs and all that kind of stuff. So when it comes to military robotics, and most of what I do is on the military side, so not a lot of civil work stuff in my group, but trying to parallelize the development of the platform and the software, because really a lot of the things we're looking at fielding is taking autonomous algorithms and then applying them to kind of a dumb platform. So providing a virtual environment that developers can use to exercise their autonomous algorithms, just start debugging, doing development, augmenting that physical testing, because that can be very expensive. It's very difficult to control the weather. It can be dangerous if you're trying to understand how this platform is going to interact with maybe soldiers or pedestrians, civilians, wildlife around it, and then that's risky. So we're trying to augment that process with modeling and simulation. So at ERDIC, we've developed the Virtual Autonomous Navigation Environment, or VANE. So it's a suite of tools that allows you to tackle this problem. We're not trying to replace physical testing. You absolutely have to have that. But using high fidelity physics-based simulations allows you to augment that and accelerate some of that development process and explore some of those environmental impacts that could adversely affect the performance and limit where you could deploy a particular platform. So as I said, it's a suite of tools. So we take a co-simulation approach. So it's as all the things that we're doing now, if it's a problem that's worth solving, it's going to be multidisciplinary. It's not one person is going to be able to just do everything. So it definitely requires a cross-disciplinary team to tackle this, because we're looking at both the physical platform and the terra mechanics of that, and the different sensor modalities. How does the autonomy perceive the environment? How does the weather degrade the sensor performance? How does it degrade the vehicle performance? Making sure we have the network architecture, so getting into the cyber piece of it, of how are these vehicles talking to each other? How are they being controlled? There's a lot of going into trying to replicate the real world in a meaningful way, so that you can understand how the actual world will impact your vehicle. So it's definitely more than a video game. We get that question occasionally. It's like, well, what you're doing different than just a video game? So this graphic tries to get at that. In kind of a human-centric video game, you get to rely a lot on the intelligence of the human, so you don't have to add a lot of physics to it for the human to kind of suspend disbelief and accept it at some level as real, and you can get instructive and insightful things out of that. But when it comes to understanding how a robot is going to interact with the real world, you have to fool it. It is real. I'm anamorphizing it a little bit, but we're replicating the physical effects, the physical material properties. How is light propagating through various weather effects, moisture content in the soil, changing trafficability. There's a lot of data that you have to put into that, a lot of science, a lot of engineering. So each one of these pictures, multiple people that are experts in the field have to contribute to allow that to be successful. It's definitely a partnership, allows you to be successful in this type of endeavor. So just kind of here's a screen capture of what our simulations might look like in practice. So on the left, we've got just a military vehicle with some sensors and some computers on it. And it is performing an autonomous navigation of a testing site in Michigan. And so this is kind of looking at the different parts of the simulation. You've got the vehicle on the left. And so we're using off-the-shelf stuff that's in Unreal Engine 5 that we're using for the multivariate dynamics. We validate the vehicle models. So we have real test data. We can calibrate the vehicle model to make sure it replicates that real world performance. We've got the LiDAR, that's the primary sensor modality for this particular autonomy stack. So how is it interacting and perceiving the world? That going into the cost map to, where can the robot think? Where does the robot think it can and cannot go? And obviously now we can change the weather. We can say, oh, we're going to lose a sensor, or it's going to be foggy, or the soil is soft and you can go half as fast as you can. And we can control all those parameters and understand, how can we improve our algorithms so that they can be more resilient to those adverse conditions. Just a couple quick applications before I yield the rest of the time to questions and answers. Having this kind of baseline capabilities allows you to quickly adapt and respond to needs. So this is an engagement we had with some combat engineers out of Fort Liberty. They were doing a large, high profile physical experiment with some robotic vehicles. And they were going to have basically 1 week with the actual platforms. And they were going to have to develop their plan of attack and kind of how they wanted to use them, either just on paper, or, that was basically their option until they actually had the platforms for 1 week. And then 2 days of that were before all the VIPs showed up. So we worked with them, quickly transitioned our tools to allow them to understand, hey, if we had this physical platform, how would we use it? How can we work as a team to execute this mission? And they were able to do that in simulation. Again, not as much of the sensor physics into this one, because this one was human-centric as a human in the loop. It was a teleoperation. But this next one, this is another partner we work with. This is at Aberdeen Proving Ground. Now they're looking at augmenting the testing evaluation of an autonomous logistics platform. And just real quickly, the big point is that bottom left bullet point in terms of the amount of time and money and environmental impact that you can reduce by augmenting your physical testing with M&S. So reducing cost by 98%, not consuming the thousands of gallons of fuel. You get those reps with the system, and you kind of hone in on where does the system struggle using M&S, and then you can really fine tune your physical experimentation, design of experiments, and understand where do we need to test and where do we need to do more development. So that was a lot. As Amet said, we work closely with academia. We leverage the BAAs and OTAs through Arctic Works as well. So be happy to answer any questions on this side.
Okay, all right. Thank you so much, Dr. Solem Mazalou and Dr. Monroe, for those informative presentations. At this time, we'd like to open the floor for questions. So please feel free to open your mic to direct questions to the speaker of your choice. If you use the chat to ask questions, just remember to indicate whether your question should be directed to the ARL speaker or to our ERDAC speakers. And so the right person can make sure that they can answer your questions. So with that, who'd like to ask the first question?
I've already written a text in the chat, but I'd like to find out more about teaming with Dr. Monroe's team in order to pursue simulation applications that build on Vein, possibly in a way that model humans within the loop as well.
Yeah, I'm sure we can, but please reach out. My email was at the end of my presentation, but if you didn't get a chance to record that, I can put it in the chat or, okay, yeah, great, thank you. So yeah, just shoot me an email and we'll find a time to sync up and chat more offline.
Thank you.
Any other questions?
They are coming into the chat fast.
I see them. Please feel free to unmic yourself and ask your question. I see we have a question from C. Sean. Well, C. Sean does have in the chat pod that he wants to know, or she wants to know, will you share the slides with the attendees later on? I think that's probably for both of the presenters.
Yes, absolutely. I did not take that question onto me. We can send them to you. Absolutely.
Wonderful, fantastic. I see Kai Lu. Kai Lu, would you like to unmute your microphone and ask your question?
Hello, yeah, I searched online, I could not find the available grants. Look like they were expired. So after this webinar, do you have any new grants opportunity? Thanks.
This is Rob Sademont from ARL. I can answer that question. It sometimes happens that there is a period of time when one grant opportunity closes and it's a few months before another grant opportunity opens. Typically, though, there is overlap. I am posting right now a link to the ARL BAA, which should be open. You'll need to click around with the buttons and do a bit of search to find a particular topic area. And there are no real deadlines for white papers in the sense that the BAA ideally never closes, but is only replaced by a new one when it expires. So Marianne and I, in my branch of ARO, we typically get funding in at the beginning of the fiscal year, so October 1st. And we, again, typically have a pipeline of proposals that we would like to fund. Sending in a proposal or a white paper and then followed by a proposal in spring works well for me. Marianne advises, let me check to make sure. She advises that for her, the best time to send white papers is October through February, and that will give PIs enough time to write a reasonable proposal by summer and submit it by then. But there are no hard deadlines, and It really depends on the program manager and how much of a backlog of competitive proposals they plan to fund. Over.
Thank you so much.
Hi, this is Janine Owens, the HBCU-MI Army Research Office Program Manager. And I just wanted to also add that we do have BAAs that are specific to HBCU-MI communities. And for FY24, we already awarded those. And for FY25, we haven't announced what those are as of yet. So right now, the best opportunity is via the open BAA that was mentioned. Thank you.
Oh, thanks. I completely neglected to mention HBCU specific opportunities. Thanks.
Yeah, no problem.
All right, do we have any additional questions?
Hi, excuse me, this is Qianlong. I have a question about the eligibility. So I read some BAA. Some BAA didn't mention any eligibility, like who can be the applicant. So if there's no eligibility, can I assume that any universities faculty are able to write the right paper to the PM? Like, does it require to be PR or citizen?
No. ARO funds research at research institutions. Typically, what that means, the eligibility is fairly broad. I don't believe we can fund students or postdocs, but if you have a permanent research position at a research university in the US or elsewhere with no citizenship requirements, then it's fine to submit a white paper or proposal.
Got it. Yeah, thank you.
Dr. Amanda, so when you say that there is no citizenship requirement, does it require us to have like a green card?
I've recently funded a researcher who is a citizen of Switzerland and who is working in Switzerland. I've never met him, but it's completely open. There, we are talking about the yeah.
Okay, yeah, thank you. And also I have a question regarding, you mentioned that you may need some volunteers to review the proposal. And I wonder, how can we become like a voluntary reviewer? Like, can we just email you, or we need to fill some forms online? Or if we do, then where can we find those kind of information?
I'm going to put my email address in the chat here so that you can just send me email and tell me a bit about your background. And so one advantage, which not everybody is told, one advantage of reviewing proposals is the same advantage of reviewing conference papers for your favorite conference. You get to see what's going on elsewhere in the world, and you get to see the difference between a good proposal and a bad proposal. What did you like? What didn't you like? It's probably a good learning experience for what you want to put into your own proposals.
Yeah, exactly. Thank you.
It looks like Firuza has a question. Does ARL have specific deadlines for opportunities for HBCUs and MIs? This is Janine again. The deadlines are only specified in the BAA. So again, when we have specific opportunities, It is specifically on there. However, the open BAA, we do not have a deadline right now. Did that answer the question?
Let's see. Do we have any additional questions?
Thank you for providing all this information. This is the first time I'm attending such a workshop. My name is Firuza Merkulova. I wanted to learn more about opportunities for minority serving institutions. So I was searching online and I found some. So would it be the best way to do to look through those opportunities?
And I guess either of our speakers can answer that, or Janine, maybe you have that information. That's a very good question, and thank you for your question. We're glad you came across this information.
Yeah, this is Janine again. So as far as the webinars such as this, we do send out the information to our the list of HBCUs and MIs that we have on file, and those are typically those who have already applied for grants and we have in our system currently. If you have not applied and not in our system, you can feel free to email myself and or Dr. Santamont in this case, and he can get the information to me and we can update you into our files. And I'm not sure how this was distributed, so I would look to Ariel or Dr. Black Khan to let you know how this was distributed.
Thank you.
You're welcome.
Good afternoon. Thank you all for joining us this afternoon. And to respond to the question, we marketed the event through ARL, as well as our team Chitra also marketed the event as well. So I believe on the last slide or next to the last slide is some contact information where you can feel free to reach out to us regarding any specific questions that you may have. Again, thank you, and we look forward to working with you really soon.
Thank you, Dr. Black Khan, for that. And so at this time, that's all the time we have for the questions today. Please use the contact information for today's speakers that you see on your screen so that you can continue discussions after today's webinar. We encourage you to take a photo of the contact information so you'll be sure to have it. While you're doing that, I'd like to remind you that the applications for the 2025 Army Historically Black Colleges and Universities and Minority Serving Institutions, also known as the HBCU-MI Student Program for Army Research and Knowledge, will be opening on October the 14th. If you have students who might be interested in a summer internship in an Army research facility, you can find more information at armyspark.com. And that's ARMYSPARK.com. And that address is already, you'll also see that on your screen right now. So we want to make sure that you have all of that contact information, that you don't miss a beat with these opportunities that you can share with your students. Again, we'd like to thank today's presenters, Dr. Saint Amant from DEVCOM ARL, and Dr. Solomazelu and Dr. Monroe, both from ERDIC. I'd also like to thank all of you for joining us today to learn about intelligent, autonomous systems research opportunities with the Army. This concludes our presentation. I hope you have a great rest of the day, and goodbye.
Thank you.
Thank you very much. Enjoy your week.
Thank you.
Thank
Great.
you.